Hello and welcome to our webinar. Today we'll focus on a case study where All3D was called upon to inspect and rectify a misalignment issue with a large industrial chimney that was prefabricated off-site. You'll hear directly from the engineers involved in this unique project, gaining insights into how they use tools like the Trimble X12 scanner and Leica ATS600 tracker to create precise 3D models and restore alignment within a tight timeframe. We'll walk you through the entire process, from understanding the initial misalignment problem to conducting the 3D scan and using Geomagic Design X to visualise and implement corrective actions. By the end of this webinar, you'll have a clear picture of how 3D scanning can transform your approach to complex construction challenges, helping you achieve higher accuracy, efficiency, and project success.
So, client gave us a call about the chimney and the staircase.
Yeah, big power station being built.
Yeah,
Big problems.
Yeah, late Friday night. I think we were just about to go home, weren't we?
Exactly, and they were basically said, "Can you get here tomorrow?" Everything's sort of ground to a halt because they've come up with this problem. What can we do about it?
Yeah, and that problem being that they had a chimney stack.
Yeah.
And a spiral staircase to go around it.
They didn't really marry up.
They weren't fitting.
No, exactly. It was a bit of a weird one, though, because we didn't really know a lot of the time, the client will call us and they say, we need a CAD model of this part.
Yeah.
Make it happen. That will get us out of problems.
Yeah.
In this case, they really didn't know kind of what to do. It was all very last minute, rush.
Yeah.
They called us as a consultant to go, can you just get here and figure this out?
Yeah, so it's more of a what is wrong.
Yes.
Than a can you make something for us? Yeah.
At the end, it ended up being something completely different, but we went in initially to go, right, well, let's inspect the chimney.
Yeah.
For everyone at home, the chimney's got a load of brackets going around the outside, ready to receive this staircase.
Yeah, where the staircase bolts onto around in a helical pattern.
Exactly.
Down around the chimney, yeah.
And obviously the two didn't fit, but they weren't sure, is it the stair which was manufactured incorrectly, or was it the chimney? So our first protocol was, right, let's get some really accurate measurement equipment down there. I think we went down with the X12 and
the ATS600 from Leica,
being sort of the longest range, high accuracy scanner that we can get at short notice.
Yes, the beauty of the 600 is that we can take points remotely, very, very accurately. Mm-hmm. It's definitely the right tool for the job.
Yeah, so the idea was we'd go down there, we'd set up in a couple of locations where we can get line of sight onto all these brackets, which being a building site was a nightmare.
Yeah. Lots
of stuff going on, telehandlers going by, us having to sit around and wait for things to happen before we can get shots onto the tower again. But so we went in, we measured all of those points, and we thought, right, the client gave us the design intent CAD.
Yep.
Drop it into Control X.
Which we can measure against.
Exactly. Line the two together, datum alignment, all lovely. And, in Control X, we can do all these lovely color maps, GD&T, we can pull off all the dimensions to the nth degree.
Yeah, didn't need to, did we?
No, we kind of, exactly. Took one look at it and went, yeah, we're not talking millimetres here, we're talking feet and inches. It was a long way out of place.
Nice mix of units there.
So, yeah, exactly. So, conversation with the client, very short one, going, the inspection isn't going to give you what you need. The problem is definitely the stack.
Yeah.
You need to
100%.
Redesign your stair to fit the stack.
Yeah.
So,
at which point they went,
well, what can you do?
Can you do that?
Yeah, exactly. So it was all very quick turnaround.
Yeah.
A lot of the time we would have reverse engineered this from scratch, taking the raw data and building it up accordingly. In this case, actually the diameter of the chimney was pretty good. And so it was decided that we would take the existing design intent CAD and we would reposition all of the flanges, because the flanges were there, they were just completely
in the wrong place. Yeah.
And position them where they are on site. So
if memory is good, I believe a few of the flanges were missing some details.
There were some different shaped flanges.
That's correct.
Yeah, so some of the flanges were the wrong flanges, but still there, and then others were just wildly out of position.
Yeah.
So that's where Design X came in.
Yep.
So the scan data goes in, same alignment as in Control X, so everything's aligned to the real world. Yeah. The real world data is aligned to the design intent CAD. And then we broke it apart. And in Design X, we've got some good alignment tools for taking CAD data and best fitting to the
scan data. Yeah.
Yeah, I think we use a combination of like datum alignments of the CAD to the scan and kind of like a best fit, and then positioning to make sure the eye holes and the flanges all lined up.
Yeah, perpendicular to the, tangential to the outside cylinder. Yeah.
So that took what could have been a big reverse engineering project down to maybe a few hours of work, which allowed us to get that data turned around to the client nice and quickly. That then got sent back off to the stair manufacturers, who went, yeah, you're right, this is very different.
Yeah.
Remanufactured the stairs
to fit. Yeah.
And then everyone was happy.
Yeah, excellent. So initially we were going to go into Control X, right?
Yeah, well, we initially assumed that it would be an inspection job. We know the stair doesn't fit the chimney, and we're just going in to confirm that it's the chimney that is the chimney's okay and the stair is the problem. So we put it in.
Vice versa.
Or vice versa. I think the client was hoping the chimney was completely fine, and it was just a bit of stair manufacturing to do. So yeah, into Control X, which is an inspection package. It allows us to take the scan data and usually the design intent CAD model, which the client provided us.
Yep.
And then we align the two together. So the alignment's quite important.
Yes.
And we've got lots of tools inside of Control X to make that happen. So we can get that scan data overlaid, and then we can choose if we're doing a best fit alignment, a datum alignment, or lots of different other ones, but those being the main ones. I think in this case we used a datum alignment. We sort of aligned the scan data to the CAD based on the axis of the chimney. Yeah. And then we clocked in, I think, to the bottom bracket, if I remember rightly. So
if I remember rightly, yeah.
Of all of it, the bottom bracket was right.
Yeah.
And then we quickly saw that it obviously propagated off and was not in the right place at all.
No.
But I think the initial plan was to be able to present the client with some nice colour maps to give them some understanding of
deviations on each flange, because we were at that point we were assuming it was a matter of millimeters, weren't we?
Yeah, that's what the client alluded to, hence why we rocked up to site with the ATS600, which is, sub-millimeter at 60-meter range kind of thing. So that was the assumption. And in Control X, we can take that data and create GD&T analysis. So we can say, right, the angle of this bracket is out by half a degree, and this fixing
position of a hole is
exactly
0.01 of a millimeter out, and that kind of thing.
Yeah. In the end, the deviation was so huge that an inspection report wasn't really going to give any useful data to the client, nothing actionable.
It was visually out, wasn't it?
Yeah.
Considerably.
Yeah. So that's when we changed tact and we went, right, we need to give them a new CAD model.
Yes, so that they could fit the stairs to the as-is chimney.
Yeah, exactly. So into Design X.
Yep.
Reverse engineering package.
And the idea was we would move the flanges into the position of as-is, so that the staircase would be manufactured to fit the current chimney rather than what we thought the chimney was going to be.
Exactly. I think typically when we put data into Design X, we would be reverse engineering from scratch. Yeah. So we get that scan data, we'll align it to the coordinate system, and then we can start building it. So extrude the tower of the chimney up and then position the brackets, pattern them around, whatever it might be. In this case, the client wanted the data really quite quickly.
Yes,
and
because it was holding them up, wasn't it?
Exactly. Everything had ground to a stop on site, in that area at least. So we got the scan data already aligned in Control X from the inspection. Yeah. So that was aligned to the coordinate system.
Yeah, imported it straight in.
Fantastic. And then we had the CAD file in there, which thankfully was broken up into its component parts.
Yes.
And then we took each flange in turn and we attached it to the scan data into its correct position. In some cases, it was the wrong flange, so we had to go and find the right CAD model and position it in, or edit the CAD model in place. So there was a bit of both.
But most of the time, they were the right flange, just in the wrong position.
Completely right.
Yeah, and we used a combination of the alignment tools, didn't we?
Yeah.
Because they were, again, the cylinder was correct, but the position rotationally was off, and sometimes vertically as well.
A little bit, yeah. I think mostly we did a data match between the scan data and the CAD to bring that CAD onto the plane of the flange.
We kept it locked to the rotational axis.
Yeah, exactly. And then from there we can constrain those degrees of freedom and then allow it to best fit to the scan data, so it becomes in the right place in terms of horizontal and vertical. Usually, this job would have been taken a long time because the chimney, although we're describing it as quite a simple thing of a cylinder with some flanges on, there's a lot of detail in there. Yeah. All these flanges have got different hole positions. There's lots of supporting steelwork. So typically, this would be potentially several days worth of reverse engineering. And that just wasn't going to sit well with the client. So we decided that we could take their existing CAD and align it to the scan data, which significantly cut down the time involved.
Well, realistically, the only thing they were interested in was the position of the flanges.
Yes.
Because the cylinder itself of the main stack was good enough to within, can you remember what kind of accuracy it was good
It's
to?
a centimetre. And there was a big standoff between the stair and the actual wall of the cylinder.
Yes.
So they had that.
So the assumption was quite comfortable that the cylinder wasn't a problem.
Yes.
So then it was just flange position and hole in flange position, which we also corrected, if you remember.
Yes. So generally speaking, we're taking the design intent CAD of a flange and we're best fitting it in some way to the scan data.
Correct.
But then a lot of the time we found that the holes in the flanges were in the wrong place.
Yep.
So then we can use some of Design X's.
Yeah, so then we'd use mesh sketch.
Yeah.
So then we can get I think we used silhouette, didn't we?
Mm-hmm.
So
works well with point cloud data.
Yeah, so mesh sketch will allow us to section through point cloud data, won't it? Or mesh for that matter.
Yeah.
Whereas the silhouette tool is part of the mesh sketch. And what that allows us to do is take a sectional area and then get the silhouette off that area.
Yes.
So that was quite nice for the holes, wasn't it? Because you end up getting partial data from each different direction.
That was it. Yeah,
So,
there was only so many points of view we could set the kit up.
Yeah.
It just being a tracker-based instrument, to move it around, we have to be able to measure common points on the building site, and they are few and far places between because nothing seemed to be staying still for long in that place. So to control everything on site, we created a control network with the tracker. So the way this works, we put some that are known as nests around site in strategic locations.
So you use a reflector for the network.
With the ATS600, yeah, exactly. So we kind of figured out where we would have to place the instruments to be able to get line of sight onto the brackets. And based on knowing where we're going to have to position the instruments, we can then find common points around the building site which we can tie into. So with the SMR, we can go and take those points very, very accurately and use those to move the tracker from position to position. Equally, we can then replace those with a small checkerboard, which the X12 could tie into. And so then we've got both data sets very well aligned together. Yeah, so they're in the same coordinates.
But the nice thing about the 600 is not only can we use a reflector, an SMR, but then to actually take the data, because these flanges were not accessible. They go up a very high, like
25 metre tower?
Something along those lines, but we can measure reflectors.
Yes.
Which is why we chose the 600.
Yeah, exactly. I think it's something like 0.3 mil up to 60 metres away, 80 metres away.
Yeah, really good.
So we get really clean data, which makes our lives from both an inspection and a reverse engineering point of view really, really easy. So I'm glad we took that on site.
Yeah.
So after we completed the inspection in Control X, it was abundantly clear that the flanges were not within design tolerances.
No.
So we went to the client and we explained the situation to them.
Yeah.
After some sighing, we decided and comforted them and said, well, don't worry, we can tell you exactly how this has been manufactured. Yeah. And therefore, you can pass that information downstream to get more
to get the staircase modified so that they will fit.
Exactly. Yeah.
So in summary, we managed to bring a lot of nice kit in to do the job.
Yeah, I think it was required though.
Yeah.
We're looking at a big structure, but the client is specifying crazy tolerances.
It's the high accuracy over large distance.
Yep.
We needed to bring 2 separate pieces of software in. We needed both the inspection and the reverse engineering software.
Exactly.
DX.
And having software which can handle inputs from different scanners, both metrology and terrestrial data, it's really key. And I think in this case, because we are working with software which historically has been promoted as a mechanical-based package, it allows us to achieve these really tight tolerances on these larger projects.
Yeah. Yeah, and at the end of the project, we managed to get the answers for the customer.
Yeah,
in a timely manner, yeah.
And actionable data which they can actively use and send downstream to their manufacturers.
Yeah, so they managed to get our revised as-is model off to the staircase manufacturer. They revised what they were making and managed to get a working staircase.
Exactly.
Onto site.
As far as I know, customers happy?
Yep. All resolved well. So with the modified staircase design, it went in, and all was good.
Perfect. That's what we like.
Thank you, Rob and Sean, and thank you all for joining us today. We hope you enjoyed it, and if you do have any questions about anything we've discussed, you can message us or visit the All3D website. Thank you.